Hello, well, this is going to be part 2 of Chapter 3, The Science of Astronomy. I'm going to go through briefly probably in the next 20 or 30 minutes. I'll give you this portion of a 4-part session of Chapter 3. So the Science of Astronomy, just make sure you get your lecture notes out, Chapter 3 in Week 2, and we'll move forward. So we're in Slide 1, the cover page. Slide 2, Section 3.1 of my lectures will show you that we'll talk about how humans employ scientific thinking, how astronomical observations benefit ancient societies, and why ancient civilizations what did they achieve regarding astronomy. In the next slide, the idea about all humans using scientific thinking is based on just everyday observations, what you see in nature, and then what you apply based on what you see, what you observe. You use trial and error to come to some conclusion in this scientific thinking. Next slide is, in this chapter, we'll learn how astronomical observations benefit ancient societies by keeping track of the seasons, the time of the seasons, and aid to navigation. Some current events in the next slide is with what I'm planning on telling you in this class. There are always going to be exceptions to all theories, exceptions to all rules. In science, you try to welcome exceptions. And if there is an exception in science, scientists try to adjust their scientific thinking in order to accommodate them. For example, this slide is a current event on Van Briesbrock star, VB10. And a planet, VB10b. It looks like, with what we can tell, the planet and the star are about the same size. VB10's mass is 70-80 times that of Jupiter. VB10b's mass is 6 times the mass of Jupiter. The mass is different, but the size appears to be the same. So what we're trying to observe right now is the orbit. How long does it take to orbit that star? It should be one particular orbit, and we'll talk about that as time goes by, but it is not apparently working the way we would like for it to work. I'd like to skip the next slide. Of course, ancient people in Central Africa, they could predict seasons. And then the next slide is the days of the week. You have it in your set there, how the days of the week were picked. And then the next slide, slide 8, will show you again that we'll be looking at daily timekeeping, tracking the seasons, monitoring planets and stars, predicting eclipses, more. Okay. There are many different monuments, features all over the world. One of them is in Egypt, the obelisk, showing the time of the day. And then you have Stonehenge in England. You also have Mexico's model of the Templo Mayor. You have the Sun Dagger in southwest United States, marking the summer solstice. And then you have Scotland's 4,000-year-old stone circle. The moon rises is shown every 18.6 years right through that stone. Yucatan in Mexico have an observatory. It's falling apart, but it's an ancient observatory left by the Mayans in Chichen Itza. Peru, patterns on the ground. You can only see the patterns from above. They were looking up and drawing these figures based on what they saw in the sky, trying to trace the sky. Wyoming, Bighorn Medicine Wheel. I wouldn't want to be there in the middle of the night. In South Pacific, Polynesians used wicker sticks to identify stars. That's how they navigated. They also identified currents in the water the same way, using those wicker, and the beads were where stars were formed, or the beads indicated where islands were found. France, cave paintings from 18,000 BC. 18,000 BC. It's a very interesting painting. It shows possibly shows the lunar phases, the 29 dots. In China, the earliest known records of supernova explosions, 1400 BC supernova. So that was the first supernova that we humans witnessed in 1400 BC. And so, based on that, is how the ancients began to develop scientific thinking. We also knew that what I discussed was they determined they could track the time and the seasons. They could navigate by the stars. They could do a lot by just looking at the stars. We also learned that the civilizations of ancient times were able to use the moon and track its cycle. It was all part of their observing the heavens. In the next section, slide number 23, it's all about modern science, how the Greeks came into the picture, okay? And then how did Islamic scientists, how did they provide input? Slide 24 is a wonderful map worth 1,000 words to show you, and what I would like for you to do is start in the Library of Alexandria. The location of Alexandria, up in the northern part of Egypt, right along the Nile River. That's where the ancients collected all of their data, all of the knowledge, all the documents that they could get their hands on. They published was in the library at Alexandria. It was burned down. Everything was destroyed. Soon after that, the Dark Ages emerged. We had the Crusades. We had, at that time, that's when monarchs took over, and the knowledge went only to the wealthy, to the scholars, to the learned. And the caste system was very clear, where the monarchs kept knowledge from the caste, from the people, kept knowledge from the people. So if you were a cobbler, for example, your child, your son would be a cobbler, but you would not have any knowledge beyond being a cobbler. So that's when it all started, called the Dark Ages. There was no increasing in knowledge at that time. It was suppressed. However, knowledge was stimulated. You see in the light colored areas, knowledge was stimulated all the way over into Baghdad, where they built the House of Wisdom. So from the Library of Alexandria in slide 25, and from the fact that the Greeks, they amassed all this knowledge into one location, we lost quite a bit of data. But one of the great things that the Greeks provided us was a model that couldn't be burned down. It was a piece of metal. We call it now the geocentric model. Slide 26 shows you an Earth-centered model, where the Earth is the center and all of the heavens, every object in the heavens orbited the Earth. Notice that the Earth is round. Notice that this date of the geocentric model is 400 BC. So it was well understood that the Earth was round well before Christ walked the Earth. However, these models, started by the Greeks, were immensely valuable. We still use this model today. It still has value. except we just don't use the Earth as the center. In this idea, though, everything orbited the Earth, the Sun included. All of the constellations, they all orbit the Earth. We did not know that the Earth rotated. We did not know that the Earth orbited the Sun. But everything everything orbited in perfect circles because God was perfect. Okay, so the other thing that was real interesting and very, very valuable was the Greeks did not explain the supernatural because it could not be observed. So they dismissed it regarding observations. They did not attempt to explain the supernatural. Okay, moving on. Slide 27 shows you that Eratosthenes in 240 BC, he knew that the Earth was round as well. I mean, we have evidence that the Earth was round, and not only that, but he was very exact in his measurement of what the distance around the Earth was, or we call it the circumference. He said it was 250,000 stadia, which is approximately 42,000 kilometers. But we know now that in modern days, the circumference of the Earth is 40,000 kilometers, 40,100. Moving on to slide 28, the Greeks had some very famous people that you probably have heard of. Plato, Aristotle. Anybody know of Aristotle? They both believed that the heavens were perfect. They both believed in monarchs. They believed that the people should be ruled. Aristotle attempted to understand democracy. He looked at 4 different types of people. We have the timocracy, the aristocrats. We had the aristocrats, and I can't remember the third one. But then we had democracy. Democracy were people that they were just good old boys. You know, if you knew someone that knows someone that knows someone, you became status. Aristocracy were people that actually had a skill. Actually, either had wealth or they had a skill. They were well known. And then the democracy, people that worked together to worked as a team to have a skill. Instead of one individual having a skill, work as a team. In democracy, Aristotle applauded the idea, but he thought it was chaotic. He did not encourage a democracy. He leaned more toward a monarch. As a matter of fact, one of his proteges was Alexander. We know him as Alexander the Great, leader of the world. Moving on. Also, a follower of Aristotle was Hitler and Stalin. They all followed Aristotle's leadership. Okay, moving on. Slide 29. There were, like I said, some things that were not explainable by the ancients. One of them was apparent retrograde motion. They knew that Mars, they didn't know that Mars orbited the Earth. I mean, that's what they thought. They didn't know that it orbited the Sun. Okay? What they also did not know is that the Earth moved faster. As the Earth orbited the Sun, it was moving faster than Mars. But because they thought the Earth was not moving, and that Mars was moving around the Earth, they could not understand why throughout the year Mars, there was a time where you can see on the slide that Mars was moving backward. Couldn't figure it out. But if you can imagine, the reason why Mars appears to move backward, and it still does to this day, in certain months of the year, if you can imagine driving on the highway, you're in the fast lane, you're passing a person on the right who is driving slower, me. And when you pass me up, we're both going in the same direction, which is key. but you're moving faster than I am. And when you pass me up, you look back at me as I appear to move backwards. Well, that is what's happening. As Earth passes up Mars, it appears to be moving backwards for a short time throughout the year. Okay. Ptolemy, another, he was a student of Aristotle. Loved the geocentric model. He realized that there was a problem with the apparent retrograde motion. Fell asleep one night, woke up with an epiphany, saying God gave him the answer to the apparent retrograde motion. And notice the year was 100 AD, 170 AD. And slide 31 is his answer to what God gave him as the answer to apparent retrograde motion. Now, it would drive me crazy if I was on, say, Mars, and I would loop-de-loop like that. That's what he thought. That's what he thought. Yeah. Okay. Now, in this thought question, after the thought question, I'm going to stop, take a break, and go to my next video. Okay, this thought question is, which of the following is not a fundamental difference between the geocentric and sun-centered models of the solar system? Okay, that's our thought question. Which of the following is not a fundamental difference between the geocentric and sun-centered models of the solar system? That is slide 32. I want you to look at it. I'm going to take a break here and look for the next part to this chapter 3 lecture. Thank you.